Okay, so hello class, welcome back. So in this recording, we're gonna take a look at section 9.3, which is estimating a population standard deviation sigma. So we're gonna get two objectives on this recording. We're gonna talk about another kinds of distribution, which is the chi-square distribution. And then the second objective, we're gonna talk about the construction and the interpretation of the interval, the confidence interval to estimate the population variance or population standard deviation. Yeah. So in this section 9.3, we're gonna talk about the method for estimating the population variance sigma squares or the population standard deviation sigma. So just as we discovered the sampling distribution for the sample mean x bars and the sample proportion p has, we must find the sample standard. We need to find the sample variance as a point estimate of the population variance, and then the sample, and then what kinds of distribution that's going to be for the um, sample variance. And then we're going to use that to construct the confidence interval to estimate the population variance using this sampling distribution. So what's going to be the sampling distribution for the sample variance S square? Okay, so what's going to be the sampling distribution for the sample variance S square? So the sampling distribution for the sample variance S square is going to follow the chi-square distribution. So what is the chi-square distribution then? So if a simple random sample subset n is obtained from a normally distributed population with the population means mu and the population standard deviation sigma, then when you calculate the calculation of n minus 1 times s squared divided by sigma square, that's going to follow the chi-square distribution with n minus 1 degrees of freedom. So that's going to be the definition for the chi-square distribution. When we do the calculation n minus 1 times it by s squared over sigma square, that calculation will follow the chi-square distribution with n minus 1 degrees of freedom. So this is the distribution for the chi-square distribution. So let's give you more definition or the characteristic of the chi-square distribution then. So the characteristic of the chi-square distribution, so the first properties or the first characteristic is the chi-square distribution is not symmetric. Yeah, so this is not symmetric. Yeah. So the chi-square distribution is not symmetric. The second characteristic is the shape of the chi-square distribution depends on the degrees of freedom, just as the student T distribution. The third characteristic is the numbers of degrees of freedom and and the minus 1 get increased, the chi-square distribution become more and nearly symmetric. The values of the chi-squares are non-negative. So just using the definition from the algebra. So whenever you take any when you take any number raised to the power 2, right, or you square it, then the answer will be non-negative. So this is going to be the chi-square distribution. So the value of the chi-square distribution is non-negative. So which is greater than or equal to 0. So this is going to be the distribution of the chi-square distribution based on the different degrees of freedom. So we have when we have the 2 degrees of freedom, when we have 5 degrees of freedom, 10, 15, and 30. So we can see that's when the sample size n get increased or when the degrees of freedom get increased more and more, the distribution for the chi-square will become more and more symmetric. Yeah, so that's going to be some of the characteristics that we have for the chi-square distribution. And we're going to use this chi-square distribution to estimate the population variance or estimate the population standard deviation. So we just got introduced to the chi-square distribution. Now let's take a look at some of the calculation related with the chi-square distribution, which is the critical chi-square. Okay. So finding the critical chi-square, the critical values of the chi-square distribution. So the notation chi-square sub alpha is the critical value, so that the area to the right of that critical values is alpha. So similar definition with all of the critical value we have, right? So alpha gonna be the area to the right. So that's gonna be the area to the right. Since the chi-square distribution is not symmetric, so we have to have two critical values. So you need to find out two critical values. So the first critical value is going to be the chi-squares of 1 minus alpha over 2. And the second critical value will be the chi-squares of alpha over 2. So that's going to be the two critical values. The answer will be different. It's not going to be opposite, look like the student t distribution and then the normal distribution. For the chi-square distribution, we have to find out the two different critical values depends on the given values of alpha. Yeah, so the first critical value is chi-squares of 1 minus alpha over 2. And the second critical value is chi-squares of alpha over 2. So traditionally, we are given a table, so we can use the table to get the answer for the critical value. But for our class, we have the program Math 200B. We can use that to find out the critical value. So this is going to be the step-by-step how we find out the critical value using the program Math 200B. So step number one, you can calculate the degrees of freedom is equal the sample size n minus 1. Step number two, you need to find out alphas. And after we got the alpha, we're going to divide alpha by 2 to get alpha over 2. And after that, we're going to get 1 minus alpha over 2 to get the area to the right. Now we're going to go to the program keys and then let's take a look at your calculator then. So we're going to go to the program key right here, everyone. This is the program key on your calculators. After you go to the program key, now you're going to go to the Math 200B. We have right here, so Math 200B. So I'm going to go down to the option Math 200B and I hit the enter key the first time, one more time, and then another one. Now, in order to find out the critical value for the chi-square distribution, we're going to go down to the critical chi-squares option number 4. Okay, so we have critical chi-square, so we're going to click on that then. So after we click the critical chi-square, you're going to input the degrees of freedom. Okay, and then after that, you're going to put the value for alpha over 2, and then, or you can put the value for the 1 minus alpha over 2 to find out the second critical values. Yeah. So the output of the either chi-square of alpha over 2 critical value, and then you're going to repeat the same process. You're going to repeat the same process. Okay. Cancel, delete that, delete that. And then you're going to repeat the program one more time so we can find out the second critical value, which is the chi-squares of 1 minus alpha over 2. Okay. So we're going to use the program Math 200B to get the answer for the two critical values of the chi-square distribution. So now let's give it a try for the first practice question. How we're going to use the Math 200B program to find out the two critical value, chi-squares of alpha over 2, and then chi-squares of 1 minus alpha over 2. So we're going to take a look at example number 1. So find the chi-square value that corresponds to the 95% confidence level. So we are given the confidence level is 95%, and we are given 18 degrees of freedom. Okay, so this question gives you directly the value for the degrees of freedom. So we're going to use it there. Okay, so now step number 1, we have to find out alpha, right? So based on the confidence levels of 95%, yeah, which is 0.95. So based on the values of the confidence levels, I'm going to find out the values of alpha, right? So I'm going to find the values of alpha. So alpha is equal 1 minus the confidence level, which is 1 minus 0.95. So after I got alpha, now I'm going to cut alpha in half. So I'm going to get this alpha divided by 2. So which is 1 minus 0.95 is equal 0.05. So we have alpha is equal 0.05. Now I'm going to take alpha divided by 2. 0.05 divided by 2, that's going to give you 0.025. And then based on the question, we know the degrees of freedom is equal 18. Okay. Now I'm going to find out the first critical value, which is the chi-squares of alpha over 2. Okay, so I'm going to find out the first value, chi-squares of alpha over 2. Okay, let me find out the notation. We use it then. Okay, so this is going to be chi-square. And that's going to be alpha over 2. Yeah. And then we insert the notation alpha divided by 2. Okay. Okay, so now we know the values of alpha over 2, so I will substitute the alpha over 2 there. Okay, so alpha over 2 is 0.025. Okay, so now we're gonna use in the program Math 200B to find out the first critical value, the chi-squares of alpha over 2. So the step-by-step is summarized on the handout, so you might take a look up the step-by-step for the handout. So I'm gonna do this again then. So I'm gonna quit this one. Okay, so we're gonna go to program and we're gonna go down to Math 200B. And then we're gonna hit the enter key twice. So one more times, right? And then we're gonna go to the critical chi-square. And now the degrees of freedom equal 18. So we should directly put the 18 in there. Now the area to the right tail is going to be 0.025, 0.025. So just give your calculator a few minutes, right? A few seconds. Okay, so now this is the first critical value. We have 31.5263. So this is the first critical value. The chi-squares of alpha over 2, 31.5263. 31. 5263. Okay, so that's going to be the first critical value. Now we need to find out the second critical value, which is the chi-squares of 1 minus alpha over 2. Okay, so that's going to be the same notation we have, but now instead of doing alpha over 2, we're going to do 1 minus alpha over 2. So we know alpha over 2 is already. So this is alpha over 2. We're going to do 1 minus that. So 1 minus 0.025. 1 minus 0.025. So we know the answer of that's going to be 0.975. Okay. And we're going to use in the same degrees of freedom, which is 18. So now we're going to use in the Math 200B to get the answer of this. So we're going to go to program, go down to option number 2 to accept Math 200B, enter one time, another, right? And now we're going to go the critical chi-square. So degrees of freedom is still equal 18. And now we have the right tail is 0.975. Okay. So this is going to be the second critical value, which is 8.2307. So 8.2307. Okay. So for the critical chi-square, we have two of them, right? So we have the chi-squares of alpha over 2, and we have the chi-squares of 1 minus alpha over 2. So for the critical chi-square or the chi-square distribution, we have two critical values. They're not going to be opposite side, right? They're going to be two different values for the two critical values. And then once again, the program that we use it to help you to get the answer for the critical values is the Math 200B. Okay. Now let's give it a try for the next question, example number 2. It's going to be similar idea, but we are given different confidence levels with different sample size. So for this question, find the critical values of chi-squares of 1 minus alpha over 2, and then chi-squares of alpha over 2. We are given 80% confidence level. This is the confidence level, 80%. And now the question gives you the sample size n is equal 30. Okay. So the calculation will be similar. We base on the confidence level, right? So the confidence level is 80%. Okay, so what is 0.80? So after I know that's the confidence level, say 80% or 0.8, I'm going to find out the values of alpha then. So alpha is equal 1 minus the confidence level, 1 minus 0.80, which is 0.20. So that's going to be alpha, right? Okay. Now, after we know the answer for alpha, we're going to find out the answer for alpha over 2. Then we're going to take alpha divided by 2. Okay, so alpha divided by 2, which is 0.20 divided by 2. That's going to give you 0.10. Okay, so we know alpha over 2. So before we can find out the critical values of the chi-squares of alpha over 2, we need to know the degrees of freedom. So degrees of freedom is equal to sample size n minus 1. And then in this case, we have the sample size is 30. So 30 minus 1. So the degrees of freedom will be 29. Okay. So we know alpha over 2. We know the degrees of freedom. So now we are ready to use in the Math 200B to get the first critical value, the chi-squares of alpha over 2. Okay. So I'm gonna copy this notation, right? Okay, to make it easier for my calculation. Okay, so now alpha over 2 is 0.10. Now let's give it a try. So everyone, you can try with the calculator to see what's gonna be the answer for this critical value. Chi-square sub 0.10. And then keep in mind the decrease of freedoms is 29. Decrease of freedoms is equal 29. Okay. So we're gonna go to the critical chi-square, and then decrease of freedoms is 29. And we have the right tail is 0.10. Okay. Now give your calculator a few seconds. So we have the first critical value is gonna be 39.0875. Yeah, so 39.0875. 39.0875. So that's going to be the first critical value. We also need to find out the second critical value, which is the chi-square sub 1 minus alpha over 2. Okay. Okay, so let's plug in the values of alpha over 2. So alpha over 2 is 0.10. So 1 minus 0.10 is going to give you 0.90 or 0.9. Now we're going to use in the math 200b one more time so we can get the second critical value, the chi-square sub 1 minus alpha over 2. So I'm going to hit the enter keys again. And then one more time. So we're going to go to the critical chi-square. And then we're going to use in the same decrease of freedom, which is 29. Okay. And then the right tail is going to be 0.90. Okay. Okay, so the second critical value is going to be 19.7677. So 19.7677 is the second critical values. Yeah, 19.7677. Okay. So that's how we use the Math 200B program to help us to find out the two critical values. So after we know how to get the two critical values, the chi-square of alpha over 2 and the chi-square of 1 minus alpha over 2, now we are ready to talk about the calculation or the formula that you need to use it to calculate the confidence interval or to estimate the confidence interval for the population variance or population standard deviation. Okay. So construct and interpret the confidence intervals about the population variance sigma squares or the population standard deviation sigma. So before we actually talk about the calculation, you have to double check the requirement, right? So let's see what's going to be the requirement for this construction of the confidence interval. So the first requirement, make sure that the data obtained come from a simple random sample. So make sure that the sample that we selected going to be at random. Now, the second requirement is going to be more strict, which is the population must be normal. Yeah, so the population must be normal. We must either know the population is normal or the normal probability plot must be approximately linear. You cannot use in the sample size to verify this condition. Yeah. So we cannot use the condition that the sample size more than 30. So it's not going to work. So you have to make sure that for the second requirement, the population is normally distributed. Okay. So after the two conditions has been checked and if they are good to go, then we are ready for the calculation or the construction of the confidence interval for the population variance or population standard deviation. So let's take a look at the formula to calculate the confidence interval to estimate the population variance. Okay, so this is going to be the formula to calculate the population variance sigma square. So the lower bound for this confidence interval is going to calculate by n minus 1, which is the sample size minus 1, times it by s squared divided by chi-square of alpha over 2. So that's going to be the lower bound. For the upper bound, it's going to be similar idea, but we're going to use in the other critical value. N minus 1 times s squared divided by chi-square of 1 minus alpha over 2. And keep in mind, everyone, we're going to use this formula to calculate the confidence interval to estimate the population variance sigma square. So if the question asking you about the calculation for the confidence interval to estimate the population standard deviation, we're going to use in the next formula. Yeah, so this is the formula to estimate the confidence interval of the standard deviation sigma. So the difference is we're gonna use in the square root. So for the lower bound, we're gonna get the square root of n minus 1 times s squared divided by chi-square of alpha over 2. For the upper bound, we're gonna do the similar calculation. The square root of n minus 1 times s squared divided by chi-square of 1 minus alpha over 2. So in this calculation, the sample size will be n, and then s squared gonna be the sample variance. You can use a calculator to get this answer for the sample variance, or the question gonna give you this information of the sample variance. And then in the denominator, we're gonna use in the two critical value, chi-square of alpha over 2, and then the chi-square of 1 minus alpha over 2. So be careful with the two formula. We have two, right? One of them gonna apply when we calculate the variance. The other one gonna apply when we calculate the standard deviation. Okay. And then actually we do have a shortcut that you might use it to get the answers answers, everyone. Yeah. So this is a summary. What shortcut we're gonna use it to get the answer for these variance or the standard deviation. So the program that we're gonna use it is the math 200B. So this is the program that we're gonna use it for this confidence interval, the math 200B. Now, after you select the math 200B, you're gonna enter choice, and then you're gonna go to the option inverse about population, standard standard deviation sigma. Yeah, so inverse about sigma. And then you have to input the value for the sample standard deviation. And then you have to input the sample size n, and then to click the option. Yeah. So you can select the option either for sigma interval or the sigma square. It depends on if you want to estimate the population standard deviation sigma, or if you want to estimate the population variance sigma square. Okay. And the next step, you're going to input either confidence levels of 90%, 95%, or maybe 99%. Yeah. So this is going to be the shortcut or the program that we use it to get the answer for the confidence interval to estimate either the population variance sigma square or the population standard deviation sigma. So we can do it by using the calculators, or you might double check the answer, or you can use a shortcut to look like get the answer for these calculation of the confidence interval for either the population variance or the population standard deviation. Okay, so I'm gonna show you two options right here. So the first example, I'm gonna show you how to use in the formula to get the answer. And then the second formula, I'm just using the shortcut directly to get the answer there. Okay. So let's take a look at this question right here, everyone. So one way to measure the risk of a stock is by using the standard deviation of rate of return of the stock. So the following data represent weekly rates of return in terms of percent of Microsoft for 15 week randomly selected. Okay, so this is randomly selected week. So the samples is randomly selected. Now compute a 90% confidence intervals. Okay, so we're looking for the 90% confidence interval for the risk. So for the risk, right? So this is for the risk. And how they do the measurement for the risk. So one way to measure the risk of a stock is by the standard deviation rate of return of the stock. Yeah, so you can do the measurement of the risk of the stock by based on the standard deviation. So actually this question asking you to construct a 90% confidence interval for the population standard deviation. Okay, so that's really much the question. We're looking for the 90% confidence interval for the population standard deviation. Okay, so we are given the data right here. So there are two requirements that you need to double check before we moving on. So the first one is make sure that the sample that we selected gonna be at random. So that's good because this is randomly selected 15 weeks. So the first condition should be okay. The second condition, you want to make sure that the population is normally distributed, or the normal probability plot is going to show you a linear trend. So for this question, we are provided a normal probability plot. So whenever we are provided a normal probability plot, we're looking for the linear trend from left to right. Okay. So look like that based on this normal probability plots, we have a linear trend from left to right. So the second condition should be okay. So the normal probability plot is approximately linear. So the data is approximately normal. Yeah. And And also the box plot show you that we have no outlier, right? So the box plot just indicate that there's no outlier. And the box plot indicate that the data has no outlier. Yeah. So that's good. Okay, so which means that the two conditions that we need to check for this calculation of the confidence interval for the standard deviation already good. So we can actually move on and work out this calculation. So before we can work out this calculation, I need to find out the sample size. So we have the sample size is 15, that's good. I need to find out the sample standard deviation or the sample variance. So the question gave you the list of the data, so I will need to input them onto my calculator so I can run the one bar stat to get the answer for the sample standard deviation. Yeah. So I'm gonna go to stat first and then edit. I'm gonna input the data onto my list number 3 then. Okay, so let's input the data in the next few seconds, right? So the first one is 5.34, 9.63, negative, I'm actually using the negative case, everyone, negative 2.38. And next one is 3.54 again, 3.54. The next one is negative 8.76. The next one is 2.12. The next one is negative 1.95, 0.27, oh, so 27. And then 0.15. 5.84, negative 3.90, negative 3.80, 2.85, negative 1.61, and then negative 3.31. Okay, so make sure that we have 15 of them. Okay, now so I'm gonna use in one bar stat to get the answer for the standard deviation. Yeah, so I'm gonna say using one bar stat for my list number 3. So for my case, I have the data on list number 3. So that's why I'm using the one bar stat for list number 3. So whichever the list that you have the data, you can specify that. Okay. So we're gonna use in one bar stat for list number 3 to have the answer for the standard deviation. And then we also need to know the sample size n. Yeah, so the sample standard deviation. And then the sample size n is equal 15. Okay, now let's use in one bar stat, everyone. So we're gonna do stat, and then we're gonna do the calculation and one bar stat. And now the list gonna be list number 3. Okay. So the standard deviation is gonna be, yeah, so 4.6974. 4.6974, yeah. So 4.6974. Okay. So we know S, we know N. So now the only thing that we don't know yet is the critical chi-square, right? So if you're gonna work out this question by hand, then you have to find out the two critical value. So based on the confidence levels of 90%, okay, so what's in 90%? 0.90. I'm gonna find out the answer for alpha. So alpha is equal 1 minus the confidence levels, which is 1 minus 0.90, what's gonna be 0.10. Yeah. So after I know alpha, so I need to cut alphas in half. Yeah, so we're gonna cut alpha divided by 2, which is 0.10 divided by 2. That's gonna be 0.05. Okay, that's good. So now we need to find out the decrease of freedom also, right? So decrease of freedom is equal to sample size n minus 1. So the sample size n is equal to 15 minus 1, so it's gonna be 14. Okay. Now I'm gonna find out the first critical value, the chi-square of alpha over 2. Okay. So I'm gonna find out the first critical value, chi-square of alpha over 2. And then alpha is a 0.05. Okay, so we're gonna use in the math 200B to get the answers, everyone. Okay, so we're gonna go program math 200B and we find out the critical, right? Okay, so critical chi-square. Decrease of freedom is gonna be 14, and then the right tail is gonna be 0.05. Okay. So we have gonna be 23.6848. Yeah, so 23.68, 23.6848. So that's gonna be the first critical value. The chi-square is about 5/2. Now, similar ideas, I'm gonna use in the same program to find out the second critical value, which is the chi-square of 1 minus alpha/2. Yeah. So this is gonna be 1 minus alpha/2, so 1 minus 0.05, which is 0.95. Okay, so we're gonna use in the same program, Math 200B. Okay, so enter. Okay, one more time. So critical chi-square. Decrease of freedom is still equal 14. The right tail is 0.95. So gonna be 6.5707. So 6.57, 6.5707. Okay, so now everything's ready. Now we're gonna plug into the formula to get the lower bounds and the upper bounds. So we know the sample size n is equal 14. We know the sample size n is equal to 14. We know the sample standard deviation is 4.6974. We know the two critical values already. So now we are ready for the lower bound. Okay. So let me copy the formula for the lower bound. Okay, so watch out, everyone. This formula asking us to calculate the confidence interval for the standard deviation. So make sure that you're using the formula with the square root. Okay, so this is going to be the lower bound. Okay, so I just copy this formula then. Okay, so now we're going to substitute the value. Okay, so that's going to be the square root of, and then inside we have the radical. So n is 15. So 15 take away 1. Times it by the standard deviation square. So 4.6974. 4.6974 raised to the power 2 divided by the chi-square is about 5/2, which is 23.6848. Okay, so that's how we calculate the lower bound. Okay, so let's use in your calculator to get the answer for the lower bound. So second square root of, and we're gonna do parenthesis 15 minus 1. Close parenthesis, open parenthesis, 4.69, yeah, 4.6974, 6974 square divided by 23.6848. Okay, make sure everything under the radical. Okay, now we can hit the enter key. So that's gonna be the answer for the lower bound, 3.6115, 3.6115. Okay, so that's gonna be the answer for the lower bound. Similar idea, we're gonna get the answer for the upper bound. So the difference between those two calculations is the denominators. Okay, so the denominator should be 1 minus alpha/2. And what's the critical value? We just calculated as earlier. So that's gonna be 6.5707. So I'm gonna copy the second input and I will just update it. Yeah, I will change the denominator. Yeah, so gonna be 6.5707 and delete that one. Yeah. So 50 minus 1, 4.6974 squared divided by 6.5707. Okay. So the answer gonna be 6.8567. Yeah, so 6.8567. Okay, so that's gonna be the answer for the lower bound. And we have the answer for the upper bound. Okay. Now, after we got the answer for the lower and the upper, now we are ready to put them together in the interpretation, right? So we can say that we are 90% confident that the what? We are 90% confident that the risk of Microsoft, yes, so the risk of Microsoft stock redundant. Yeah, the risk of Microsoft stock will lie between the lower bound 3.6115 and the upper bound is 6.8567. Okay. So that's going to be the wrap up for this calculation. We just complete the 90% confidence interval to estimate the population standard deviation. Okay. So before we can wrap up this question, let's double check the answer with a shortcut, right? So we do have a shortcut that you might use it to double check the answer. And the shortcut we're using is going to be the Math 200B. So we go to Program, Math 200B. Okay. Enter one more time. Now we're going to find out the inverse about, we're going to use an option number 5, inferential statistic about population standard deviation sigma, option number 5. Now, after you select that option, the calculator will ask him for the sample standard deviation, so 4.6974. So 4.6974. Now, the next one is the sample size n is equal 15. And now, what's the option we're going to select on the screen? We're going to do the confidence interval for the sigma, right? Not sigma squared, because we do the calculation for the standard deviation. So we're going to use an option number 1, sigma interval. The C level going to be 90%. You can put 90s or 0.9. Yeah. Okay, so give you calculate a few seconds. So this is going to be the lower bound. So lower bound is 3.6115, and then the upper bound going to be 6.8567. So the answer is imagine what we just completed. Yeah. So you can do the calculation by hand to estimate the confidence interval for the population standard deviation or variance, or you can use in the program Math 200B to look like expedite your calculation. Okay. So this is the first example. You can take a look at this work right here, which just show the step-by-step how we approaching the answer to estimate the confidence interval for the population standard deviation. So for those of you who enjoy working with a shortcut, let me take you to the second example right here. And I'm going to show what is your work that you might need to show on the homework or on the test, right? So to convince me how you got the answer then, okay. So the following data represent the age at which the baby first grow based on the random samples of 12 mothers conducted by Essential Baby. So based on the sample number 5 from the previous section, we know that the data come from a normal population, a normal distribution, so that's good. Construct a 90% or 95% confidence interval. So we're looking for the 95% confidence interval for the population variance. So that's going to be the population variance of the age at which the baby first cross. And then don't forget you need to interpret the results. So this is going to be the 12 number or the 12 data that we have right here. So I'm going to input them onto the calculator first. Okay. So we're going to go start and we're going to go to edit. I'm going to go to my list number 4. So this is 52, 30, 44, 35, 39, 26, 47, 37, 56, 26, 39, 28. Okay. So make sure that we have 12 of them. So that's good. So let's read the question one more time. We're looking for the 95% confidence interval for the population variance. Okay, so the question gave you the original data. So before we can move it on to the calculation, you have to double check the requirement, right? So the first requirement, make sure that the 12 number that we have right here, they're gonna be at random. So this is based on a random samples of 12 mothers. So that's good. This is a random sample. And then we also know that this is a normal distribution. So the two conditions should be good. Now, if the condition has been checked, now we are ready for the calculation of the confidence interval. So once again, keep in mind, we're going to do the population variance. Okay. So before we can move it on, I'm going to show, we need to use one bar stat. Okay, so we need to know the sample standard deviation S, and we need to know the sample size N now. Okay, so we're gonna use the one bar stat option to get those two values, right? Okay, so let's use in one bar stat on your calculator for the list number 4. I have my data on list number 4, so that's why I'm gonna use in one bar stat for list number 4. Yeah, so we're gonna go start, and we're gonna go calculate one bar start, and now I'm going to change in the list to list number 4. Okay, so we have the standard deviation is 10.0011. Okay, so that's going to be 10.0011. And then the sample size n is equal 12. Okay, so that's good. Okay, so if you're gonna use the shortcuts, everyone, then you just need to give me the name of the shortcut. Then you say using Math 200B. Okay. Okay. So let's see what's the input that you use it then. Okay. So let's take a look at Math 200B, how we're gonna get the answer. So we go to program Math 200B. One time, one more time. So now we're gonna do a confidence interval. So we're gonna go down to option number 5. And now what's the standard deviation? We're gonna input 10.0011. Now the sample size n is equal 12. So which one we're gonna do, 1 or 2? We're gonna do option number 2, right? Because that's in the population variance. So that's why we're gonna use an option number 2, the population variance. So what's the sea level? The sea level is 95. So you can put 0.95 or 95, that should work, yeah. So 95%, so 95 or 0.95. So just give your calculator a few seconds. We have the answer for the lower bounds and the upper bound. So we need to input the sample standard deviation. I will just copy this again. And we need to input the sea level. So the confidence levels, which is 95%. And then we just quote the answer from the calculator. So the lower bound gonna be 50.19. Yeah, so 1934. So 50.1934. And then the upper bound is going to be 288.3424. 288.2434. So that's going to be the answer for the lower bounds and upper bound. So if you're going to use any program, any shortcut to get the answer, just show me the name of the shortcut. So we're using 1 bar stars, and after that, we're using Math 200B, and that's how we got the answer from the calculator. So we need to wrap up this question by the interpretation, right? So we are 95% confident that the population variance, yeah, so the population variance of the age at which the baby first crawl will lie between the lower bound is going to be 50.1934 and the upper bound is going to be 288.2434. Yeah. Now, just in case, what's going to be the unit for this answer then? So this is going to be 50 point what? And then 288 point what? So because this is going to be the variance, so we're going to get the unit square. So this is going to be in terms of week. So they're going to be week square. Okay, because this is going to be the variance. So that's why we have the unit square. And there's going to be week squares also. Okay, there you go. So just in case if you want to show me the shortcut that you use it on the calculator to approach the answer, there's really much what's in the work you need to show. Just give me the name of the shortcut that you use it and what are the input that you use it for the calculation. And after that, you can quote the answer from the calculator. Okay. So this is the second example that we have on this section 9.3, which is the estimation of the population variant of population standard deviation. Okay, so I will stop the sharing at this point, everyone. You might stop the recording or review this recording one more time before you can attempt the homework question, right? So I will see you next time for the next recording. Yeah.